Hello again, Tom from Every Step Calculus, everystepphysics.com. Trying to get through these partial fractions. I'm trying to do the easy ones, or possibly the ones that might be on a test. Generally, they're actually hard. You know, this, of course, partial fraction is always hard. But I wanted to do the elementary numerators on it and show you how to do that. Let's do it. Index 8, get through these quick here. Index 8 to get to my menu. You buy my programs and then you put in index 8 here in the entry line here as instructed, and then because of the open and close parentheses it runs the program, and the program is my main menu which comes up here. And I'm already at partial fractions here to speed up the video here, make it a little bit less time consuming. Press enter. We're in partial fractions. We're going to enter the integral, which is here. You have to press alpha first. For instance, you press alpha and then x divided by x4 plus etc. what the function is in the entry line here, okay? And I've already programmed it in here so that the simulator sometimes screws up because of using the cursor here, the mouse to access certain keys and stuff. So, but remember, you're going to put alpha first, and then you put the thing, and you know, x divided by x to the fourth, etc. So you get the picture there. Okay, cool. I've already entered it. Here it is here. I say it's okay. You can change it if you want. Go back and change it. In all my programs, we're going to factor the denominator. You could do that, couldn't you? Couldn't you factor this? Maybe we could if we were right into it like in algebra, but you know, right now you probably couldn't. Anyways, here's the factor of the denominator. And we're into the program. We're setting it up, etc. You do everything. You're multiplying the left side times the denominator to get rid of the. We're trying to get rid of the denominators here. We set up the partials on the right side and multiply that side times x squared plus 4 squared to try to get rid of the denominators also. So here we're multiplying the factor denominator times the partials which we set up here. Anytime there's an x squared, you're putting it x times a times x and then plus b, and then cx plus d for this second partial here. Eliminate the denominator. So here's what we're multiplying. We're breaking out the x squared to the second power here, which is really 2 of these, right? X squared is 2 of these. Here we have this, so we're going to be left with one of those. So here's the answer, a times x plus b times x squared plus 4. Same thing with the cx plus d, except we get rid of the denominator totally because this is exactly the same denominators, you know, or times the numerator, so they completely cancel. And so we put it together here. Now we're going to multiply ax plus b times x squared plus 4 using the FOIL method. We come up with this here. We combine like terms. We get x squared, etc. Just what you see here. Write this on your paper, everything you see. We're going to equate the coefficients of the left with the right. And so you know that there's no x cubed, so there must be 0 for x cubed. And here's ax cubed, so a must be equal to 0. Same thing with the b. There's no x squared, is there? No. You don't see an x squared here in the numerator? No. So we have 0, x squared, b equals 0. Whoops, we do see a 1 here in the numerator here. Here's 1 x. Okay, 1 times x here, so 1 is the equals 4a plus c, and so then c must equal 1. Okay, makes sense. And then of course there's no constant on the last here in the numerator, so 0, d equals 0. So we've figured out all the partials here. Here's the original partials, and we're going to substitute in what we found. Here's 1 over x here, 1 in the x. Okay, now we're going to do the integration of that. There's only one integral here, x divided by x squared plus 4 to the second power. And here's the integral. So we're going to do that with u substitution. And don't think about this too much. Just write this stuff on your paper. You can understand it if you want. If you want to take time and understand it here, u equals x squared plus 4 is always inside the parentheses. That's what the u equals. U is always equal inside the parentheses here. And then du is equal to 2x plus dx, and then we put the 2 on the other side to isolate this x over dx, because that's what we have in the numerator here, x times dx, see? So we've eliminated that with u substitution. And so we do using u substitutes, u is in here, and get all the u's straight. Then we integrate, and it turns out to be minus 1/2 over u, and then we substitute back in what u is equal, x squared plus 4. So here's the answer. So the complete answer of the original integral here is equal to minus 1/2 times divided by x squared plus 4 plus c. Pretty neat, huh? EveryStepCalculus.com. Go to my site, buy my programs, and pass calculus, that's for sure, and pass physics too if you want. Really great programs, okay? So good luck in your classes. I'll help you all you can if you buy my programs in calculus or the programs. Have a good one.